Hello, ladies and gentlemen. Today we are going to continue to talk about adaptations, specifically 712A, having to do with hollow bones in birds. State of Texas wants you to be able to explain how this internal structure, this is found inside the bird, allows for birds to be successful. How did that adaptation, that change that happened inside their body make them more successful and able to live in their environment? So here are two really good pictures that depict what the inside of some of the bird bones look like. And you can see there's lots of space, lots of air space within both of these cross sections. But you also see these structures called struts. And they are basically, if you can imagine, maybe like columns and stuff that hold the bone and make it very, very strong. Even though you have lots of air space, they are a very strong bone. Here's another picture showing, again, lots of airspace, but you have these struts built in within the bone that makes those bones light yet very strong. And if we compare it to this bridge here, we can see these different designs that these are called struts. And you can see they're not solid, but yet they're very strong and can hold up that bridge. And here looks like there's water underneath. It still makes it very strong to hold up the bridge itself and, of course, the vehicles or whatever would pass through it. So the struts we see in the birds, we copied that to buildings and stuff that we have. And again, it makes them very strong, just like it makes these bird bones very strong as well. Let me play this video that talks about these hollow bird bones.
Bird flight is beautiful, right? Like, wouldn't it be amazing if humans could fly? The answer is, unfortunately, no, because birds have so many compromises built into their bodies to enable them to fly up in the sky. Things that make them lighter, stronger, or more rigid. Let's take a tour through bird bones and I'll show you what I mean. Many bird bones are thin and delicate, which helps save weight, and many of their bones are hollow. Hollow bones should technically be lighter to allow the bird to lift themselves into the air. More on that in a minute. But you know what mammals do on the inside of their bones? They have marrow, which is where red blood cells are produced. You know, the things that let us absorb oxygen. Hollow bones can't do this, which is a compromise. So birds have some bones with marrow, specifically this part of the wing, this part of the leg, this part of the spine and hips, the wishbone, and the shoulder blades. Side note, there are birds which have no hollow bones. Loons, penguins, and puffins spend lots of time swimming, and they each have lost their hollow bones. We think the extra weight helps them to dive. Strangely, flightless birds like the ostrich and emu do have hollow bones. Hollow bones are more brittle than solid bones, and you can kind of tell by looking at the skeleton that the bird's bones are not able to take a hit from a predator. Birds rely on their ability to escape into the air and never be hit in the first place. Another cool thing about bird bones is that birds have found use for this extra space. Their respiratory system connects into some of their bones, which means that when they breathe in, some of that air is stored inside of their bones. But we're not done, because bird bones are hollow, but they are not actually light. If you took a living bird and a living rodent that weighed the same, then compared just their skeletons later, their skeletons would weigh the same as well. Which is strange, right? You would think that hollow bones would make them lighter. But the solid part of the bird's bones is also denser, leading to an equal weight. It turns out that hollow bones are not a weight-saving strategy, but a way to get a strong, stiff skeleton that can withstand the forces of flight. It's a two-level compromise where the bird needs a strong skeleton to fly, but it also needs a light skeleton to fly. So many other useful functions of bones are lost. I hope you see now that birds gain a lot from their ability to fly, but they also sacrifice other things to make that happen. I will be making more videos about the compromises built into birds that enable them to fly, so subscribe to know when one of those takes off. You can also watch other videos on this channel. Thanks for stopping by this week to learn what makes life awesome.
You're welcome. Alrighty, so
bird flight is beautiful, right?
He's pointing out something important to us, and as he said, it's not necessarily that these hollow bones make the bird lighter. It is that it actually makes them stronger, and air from their respiratory system, from their lungs, actually flows through the
bird flight
actually flows through these hollow areas. So again, the drawings that are gonna be in your interactive notebook are comparing what the bird bone looks like to the human bone, where the bird bones have large air pockets and these struts. The bones in humans and other mammals are filled with marrow in the middle, and then with this hardening calcium. So you can either draw this picture there, or you can, here's a real version of a drawing, and it is comparing them. So it says bird bones up here, but notice this is the human bone, and this is the bird bone at the bottom of your notes. And it says birds are lightweight, they fly for long distances, and the bones also help them get oxygen quickly to fly. And this last point of it getting oxygen quickly to fly is because they have it stored within their bones. They can kind of just push it into their lungs to be able to fly away very quickly, like when you see a predator coming, or you scare a bird, you can see how quickly they can get away. So again, bird bones are built hollow, but yet very, very strong, with these struts that are located within the bone itself. And that is the end of this topic on hollow bones, and tomorrow we'll have another. Have a good day.